Well, good morning, folks. Why don't we get started? I want to introduce myself. My name is Tobin Munsat. I'm the grad director, or the associate chair in charge of the grad program for the physics department. This is Jean Nishaun, who I presume you've been getting a lot of emails, mostly from Jean, maybe a little bit from me. I'm really glad to see all of you here. You know, a finite percentage of the time when we have these spring get-togethers, we'll have some giant snowstorm, you know, right during the day when everybody has to travel, and it kind of clobbers everybody's travel plans. So it's nice to see that everybody got here and the snow prediction sort of fizzled out. The university has relaxed its mask requirements. And so formally speaking, you don't have to wear a mask, but I would just kindly request, you know, we're all in a kind of a tight space here. So I'd kindly request that if you don't mind, it might be better for everybody if we're all masked up. So I'd appreciate that, but it's up to you. Whenever I go on an airplane, I'm always, it's sort of a running joke with me and my family, how many times people will say, welcome, welcome, we welcome you to this flight. And then the next person comes on and says, welcome. And then the next person says, welcome. And then they start their talk and they say, welcome. And, you know, you can count, it's like 15 times. You probably all experienced this yesterday. So anyway, with that spirit, welcome to Boulder and welcome to the University of Colorado and the physics program. This is a picture, you know, most of the time it's clear and beautiful, but this is just a nice picture of, you can see when you walked in this morning, you probably saw an even better view than this, because there's this kind of powdered sugar snow on all the flat irons. These mountains up here, these sort of uprising rock formations are called the flat irons because they look kind of like irons. The most visible thing is the football stadium. You are here. So this building is the physics tower. This building is the Gila Tower. And we're sort of down behind in one of the extensions of the Gila Tower. But we'll have a tour later where you see all these things and sort of tour through and get a little bit of a lay of the land. The buildings were not all built at the same time, so it can be a little bit maze-like, but you'll get the hang of it by the end of the day. Welcome. So I'm the Associate Chair for Grad Studies, and I'm a good person to ask if you have questions related to things like physics or careers or research or faculty members. And this is Jean. And you know Jean from emails, and she's the grad program assistant, and she's the person you should talk to about, most importantly right now, travel and paperwork and deadlines. And if you come to CU for grad school, she's the expert on administrative sort of things. And we tell all the grad students, never trust a faculty member with administrative things because they get it all wrong.
True.
Yeah. So anyway, Jean, you have a few words?
Yeah. Hello, I'm Jean, as Tobin said, and I know exactly nothing about physics. Actually, I don't like physics at all.
Jean, can actually come over here and speak from this side, just so the microphone picks you up.
Okay. I'm not very tall either.
That's fine. You don't have to stand behind.
Okay.
Anyway.
Yeah, I am not a physics person. If anybody wants to talk Near Eastern archaeology, I'm your person. But I know the physics, like Tobin said, all the paperwork, all the rules and regulations and that stuff. So Tobin and I have a good partnership. He does the physics stuff. I do the administrative things. I'm not going to take up very much of your time right now. I have asked all of you, and most of you have complied about sending me your travel receipts. I said I need all the details. If you're driving, I need, you know, starting and ending points and so forth. The only thing I did want to say is if you are an international student in this group, we do have 13 international students. I do need at some point today, preferably, I will not be here tomorrow, to see your passports. I need to scan your picture on your passport, your visa, your I-20 forms. And again, not all forms are applicable to all students. because of your different kinds of visas. But I do need to submit that to the international tax people. So it's not a straightforward travel reimbursement. I will fill out the forms for you. I send it to international travel, and then they will send you your check. If the address I'm using to reimburse you is the address you put on the Google form when you signed up for the weekend. If you want a different address, please let me know. Right now, I'm still working on last week's group, so I'm not going to get to yours for a little bit. I will try to get to it in another week or so. And so again, if you have a different address, let me know as soon as you can. And now I'm going to introduce you to Charlie.
Yeah,
Charlie being one of my favorite part of my job is the grad students. I've been here a long time, and a lot of the grad students have become my friends, Charlie being one of them. He's in charge of Saturday after NIST tour activities to lead the hike and maybe to Pearl Street. So Charlie?
Yeah. Hi, I'm excited to see you all today and then see you for a little bit longer tomorrow. We're going to do 3 different activities probably. Some people will do some hikes, and some people will just head over to Pearl Street, which will be just a short walk that way. So for the hikes, we'll have one hike that'll be a little bit flatter and one hike that'll be a little bit steeper. Neither one's going to be like a crazy adventure or anything. They're both just going to be fun hikes on the trails in your town. But if I could just get a show of hands for how many people would want to do each one, that'll help me with some planning. So how many people think that they'll just want to walk over to Pearl Street and see sort of downtown Boulder? It'll be fun. It'll be really, I mean, all these things are going to be really fun. I think that like Pearl Street's a really fun neighborhood, and it's a great place to get a sense of what it'll look like, because we'll hopefully spend a lot of time there. So Pearl Street.
All right, just here.
Great, cool. How many people think they would want to do a sort of, did you have a question? Yeah. It'll be probably 2 to 3 hours. I think that we'll once we get to each hike, we'll split into smaller groups, partially so that we don't mob the trails, and partially so that each group can decide how far they want to go. But I think that like between 2 and 3 hours would be sort of what to expect. So how many people think they would want to do a flatter, gentler hike?
Raise them high.
Yeah, thanks. And steeper hike.
Raise them high.
Okay, great. So that just gives me a general sense of how many people want to do what. Once we get there in the morning, obviously, I'm not going to hold you to it because I didn't take down any names. But that'll help. So we'll have some people there with cars, and that'll help me just figure out how many drivers to assign to each different hike. And then once we're all together, I'll sort of say, these drivers over here will do a steeper hike, and these drivers over here will do a less steep hike, and we'll all head out to the trails and have a great time. Cool. And then also there will be a couple people who will lead the walk over to Pearl Street, and it'll be really fun. All right, thank you.
There are a few chairs here in the middle if you want to gather in there, or else, whatever works. Yeah, there's like 5 or 6 chairs over here if people want to scoot in. So I'll press forward as people are finding their seats. Like every program or like every university, the primary place to find information is the website. So if you haven't already, I encourage you to visit the website. We're also going to have a lot of this material up online, so you can revisit things or revisit talks and revisit lab tours and posters on a grad recruitment site. And we'll email that out at the end of the weekend. I want to just start with a few facts about the physics department. We are as you well know, we're a very large department and a very diverse department. So there's really not like just one thing that Colorado does. We have over 50 faculty in the department. And maybe one of the most important things to understand about Boulder is that it's not just the faculty in the physics department who are doing research and who are doing research with grad students. We have lots of interdisciplinary programs and opportunities outside the physics department. Boulder is kind of a centerpiece of physics and physical research in the whole central, what we call the Front Range area. All these acronyms sort of mean some institute or department. The electrical engineering department, the astrophysics and planetary science department, NIST, which JILA is a collaboration between NIST and CU Physics, LASP, which is a big space physics organization. National Renewable Energy Laboratory is just down the road in Golden. The National Solar Observatory has its headquarters in Boulder. CASA, NCAR, National Center for Atmospheric Research, is just up on the hill above Boulder. So Boulder is really a kind of a center of national and international research, and the physics department sort of has connections with all those places. And importantly for you, people, grad students, do research in all those places. We have, in addition to the research, which is we're probably most well known for, we have a very strong commitment to teaching and outreach. We have 2 U.S. Professor of the Year awards in our department. These are not, these are awards that are given across all disciplines, not just physics, across the entire country. And 2 of those award winners, primarily for teaching, are in our department. This is a fantastic location. Boulder and the areas around Boulder are always on these best places to live lists. And what I think you'll find is that most people who are here and most people who visit Boulder sort of never want to leave. You know, it reminds me of when when people go on vacations to Hawaii, there's always some moment when people think to themselves, you know, why don't I just stay? You know, why don't I just find a way that I can just stay here forever? And then you sort of think about, okay, I got to work and I need to make money. But Boulder is, in my mind, one of those places. And I know for myself, I never want to be anyplace else. Another point that I want to make, which I think is very important for all of you, which is that grad school is hard. Whether you come to CU, or I know I've seen all of your applications. I know all of you are very kind of high-powered individuals, and you're going to go to CU or another top school, and you're going to be in a difficult grad program. And that's just the way it is. And that's, I think, what you're all looking for, something which is challenging and gets the most out of you. I want to make sure that you understand that everybody who comes to CU, it is our intention that they graduate with a PhD. And the reason I bring this up is because some universities, especially more in the past, might have a reputation for admitting more people than they intend to graduate and sort of weeding people out over the course of the program because they need a lot of TA support to teach the classes. And I want to be very clear that that simply does not happen here. We, sometimes people choose to do something else. That's fine. That's your personal decision. But our intention is that every single person who comes in to CU is going to graduate with a PhD. And we do everything in our power to provide the support to make that happen. So anyway, I think that's an important point to get across. We always end up high on the rankings. We're one of the best physics departments in the world. We're even higher up on the rankings if you just look at public physics departments, because there's a lot of stiff competition from private physics departments. We have, like I said, we have research areas in lots and lots of different areas. So I've listed them all here. I won't read through them all, but I also want to make the point that each year that goes by, the boundaries between these areas get sort of fuzzier and fuzzier. So we just, for example, we are probably going to be hiring a new faculty member in the next few years in the area of climate science, which is going to be sort of a cross between geophysics and plasma physics and maybe some chemical physics. And up and down the line, there are connections. And as we get, newer and newer faculty as the decades roll by. People are just doing more and more interdisciplinary research. So that's one of the aspects of a big department that's actually very positive, that people find lots of crossover. And you have a lot of freedom to wander around and find whatever research area works best for you. I know that everybody put on their application, you know, what your preference for research area is or what your idea is of what your research is. But I promise you, we never hold you to that, and you have complete freedom to find whatever advisor or whatever research area you want to do. I know I'm in plasma physics, and only about half the students who I have graduated over the years came in to CU thinking they wanted to do plasma physics. And about the other half, you know, it took them a while to realize that plasma physics is the best of all the disciplines. So they found me, but they did it eventually. What else can I tell you? This is, like I said, this is a really large program. We have a total of about 300 PhD students over all the years. We typically have a class size of around 50. This year we had 1,052 applicants, which is not an all-time record, but we seem to be growing and growing and growing every year. I think the largest, from the data that I can find, the largest programs in the country, it's pretty close between us and MIT. And we produce something like 2.5% of all the physics PhDs in the United States. So this is a large program, but you know, the size of the program isn't the most important thing. The quality of the program is. We have 4 Nobel laureates, all since 2000. I'm not aware of any institution, university, or otherwise that has that kind of success or record. Eric Cornell and Carl Wyman won the prize in 2001, Jan Hall in 2005, David Wineland in 2012. All 4 of these characters are also members of the National Academy of Science. We have other National Academy members, Margaret Mernan, Noel Clark, June Yi, and Henry Kapteyn, some of whom you may be meeting with today, including the Nobel Prize winners. We also have MacArthur Genius Grant winners. Margaret Mernan, who you just saw on the previous slide as a National Academy members, Anna Maria Ray, who probably several of you are meeting with, and Debbie Jin, who is sort of a sad part of the story. Debbie unfortunately died a few years ago prematurely. She was a young, brilliant superstar of our department. But anyway, she was also a MacArthur Genius Grant winner. I made this point that there's a lot of research happening in Boulder that the physics department is kind of central to, and grad students are engaged with. So we put together this graphic where there are these kind of rings. So the inner ring around the Department of Physics are other departments on campus with whom we have close collaborations. Outside of that are research centers, and they all have acronyms, and I can talk to you about those, or you'll find out about them. But these are both, a lot of these are in Boulder, and some of them are just national centers or national research labs. And then the outer ring are companies and other schools, many of which are actually started by CU graduates. And tonight at the banquet, we're going to actually have a panel with some of the people who have started companies. And, you know, it occurred, this is the first time we're ever doing that. So it's not clear how it's going to work, but we thought that you might be interested in what happens at the other end of a PhD when some money starts to be earned or something. I don't know. I've heard about it. I'm not really that familiar with it, but I think that there's money involved. I want to highlight a few of these that are particularly important or relevant to a lot of you. Obviously, GILA, which is where we are right now, a pretty sizable fraction of the physics program does research in GILA, which, as I said, is a collaboration between the physics department and NIST. And walking around campus, you'll see 2 tall towers. that are like, I think the tallest buildings in Boulder. One of them is the physics building and one of them is the GILA building. So we're very close with GILA. LASP, which is a large space physics organization, does a lot of instrument development, involved with a lot of missions. Actually, CU is the #1 recipient of NASA funding of any university. So this is sort of a major source of research excitement. And Sasha Kempf, one of our Frontiers speakers this morning, will tell you some of the space physics that's going on. RACI, which is a collaboration between physics and the National Renewable Energy Laboratory, like I said, down the road, 40 minutes down in Golden. CIPS, which is a Center for Plasma Studies, which I'm part of. In the outer ring with national labs, NIST, of course. Not only is GILA a collaboration with NIST, but one of the 2 NIST campuses is about a mile away, also in Boulder, not on campus, but also in Boulder. So people do research at GILA and also over at NIST Boulder on Broadway Street. National Renewable Energy Laboratory, I mentioned. National Solar Observatory, there was a stiff competition for where that headquarters would be, and Boulder won that competition. So the international headquarters, it's called the National Solar Observatory, but of course it's an international collaboration, and that headquarters is in Boulder. NCAR, like I mentioned before, National Center for Atmospheric Research. At some point, if you look up on the Flatirons, there's this gorgeous building up on the hill, which was designed by this famous architect, I.M. Pei, who he's probably most famous for making that pyramid in front of the Louvre Museum in Paris. But he also designed the NCAR building, so that's super cool. There are companies around that do all types of physics. TechX was started by one of our faculty members, John Carey. It does sort of high-powered computation. KM Labs, K stands for Captain, and M stands for Murnan. That was a company started by the Captain Murnan research group on our faculty. Cold Quanta is a company that makes sort of compact, portable quantum systems started by one of our faculty, Dana Anderson. And so, again, we'll talk to some corporate or entrepreneurial types tonight at the banquet. Just to highlight, to go back to our teaching strength in the department. Steve Pollack was the U.S. Professor of the Year in 2013, 9 years ago. We also have several other award-winning educator. Noah Finkelstein was also a presidential teaching scholar. Kathy Perkins is in charge of the PhET physics simulations programs. Have any of you ever used the PhET simulations? Sometimes in high school, sometimes as undergrads. That was all actually started here at CU Boulder. Carl Wyman, who won the Nobel Prize for with Eric Cornell of creating Bose-Einstein's condensates in the lab, after he won the Nobel Prize, he decided to branch out and try something new. And so he started thinking about physics education issues, and he started the PhET program, and that's now run by Kathy Perkins. Mike Dobsons, Chuck Rogers, Oliver DeWolf are all award-winning educators, and there's just a culture here where we take our teaching extremely seriously. A lot of people will ask some real basics about sort of the schedule or the mechanics of getting a PhD. So I've got a slide on that. Typically, people take classes their first couple of years and then find a research group at some point during that time. The best thing is if you can find a research group during your first year so that you can start working as an RA over your first summer. You need 30 credit hours, which is 10 classes to graduate. That's one of the requirements. And so people typically take either 2 or 3 classes a semester and knock out those 10 classes over the course of the first 2 years. There's flexibility in all these things. I'm just giving you sort of the typical path. We have several sort of milestones that we call comps 1, 2, and 3. So Comps 1 just means passing with a B- or better 5 of your 6 core courses. So you get to choose out of these 6 kind of standard courses to pick any 5 of them. And if you pass all 5 of those, or at the time that you pass all 5 of those with a B- or better, then you've passed Comps 1. Then we have a second sort of milestone, which is Comps 2. People typically take this in their 3rd year. For this, you write like a 10 or 12 page introductory paper on some topic which is a little outside your research area, sort of a broadening exercise. It's a basic paper, kind of an introductory physics today sort of level paper. You give a 20-minute presentation, and then there's questions about your topic and questions about general physics, mostly really to cover undergraduate physics, just to make sure that you have the basic level to get through and start your research. And essentially everybody passes Comps 2. Sometimes I get the question about, this looks like a weed out. Is it going to be a weed out? And it's not. Sometimes people don't get through some part of Comps 2 the first time and they have to retake it. But eventually, everybody who is wanting to go forward with a PhD gets through Comps 2 and moves on to the research part of the PhD, which is really the most important perhaps, or the most central part of the training of the PhD. And then finally, I'll come back to your question. Finally, we have Comps 3. That's typically done in the 4th year. That's after you've joined a research group and you put together a committee so that it's not just you and your advisor talking about your project, but you have a little bit of an outside view and you sort of present, okay, I've gotten a start on my research and here are the steps that I think my advisor and I think that we need to do to finish this thing out and graduate. And then the committee can chime in, well, you want to write this program, but I know from my experience that that's going to take too long. And so maybe you should dial back that part. But this other part is really interesting. And in fact, I've got advice on how you might do that or whatever. But the committee gets involved just to be helpful, to keep everybody on track, to keep you and your advisor on track. Some people consider this to be like an exit strategy. You sort of lay out the roadmap to finishing up your PhD and graduating. There was a question over here somewhere. Yeah. No, they don't. So the way it works, if you don't pass Comps 2, the individual parts of the exam are sort of assessed separately. So a common thing might be this person wrote a great paper, they answered really good questions about their paper, but they didn't really do very well when we answered the general questions. So we want them to retake just this part, right? So go back and review your undergraduate physics for a month or 2 and come back and do it again. And then, people will pass the second time. It's pretty uncommon that anybody fails. I shouldn't say this probably, because you're not going to take it seriously. But people, in my experience, do a good job on the paper. And it's just interesting. It's just interesting to learn a new topic. You get to choose your topic, and people choose stuff that they're interested in. And then they learn about it, and they write it up, and they practice writing. And it's sort of fun. And then they do a good job, and they pass, and they move on. So did that answer your question? Yeah. It's supposed to be, well, it's a little bit up to the comps chair to decide that, but it's meant to be, for you to broaden out. So, if I'm doing, I guess to answer your question most directly, it's really supposed to be something which is outside of your direct research, right? So it's not meant to be, something which is going to make it in as a chapter of your dissertation, but something which really broadens your horizons and allows you or enables you to learn some part of physics that you might not have learned about otherwise, but also something that's interesting to you. Does that answer it? Okay, yeah. Yeah. So the question is, what kinds of questions? So it might be, usually they're kind of sort of practical questions. So, there might be a question like, I have a laser pointer and I'm pointing it at the board, and it's a 5 milliwatt laser pointer. How much pressure is it putting on the board? And so you don't always have to answer that question with a, you don't always have to like get it right. But the point of the exam is to just discuss with you and see if people can just talk about physics in a knowledgeable way. And so a student might sort of, think about it and say, well, I know photons have momentum, so let's think about momentum. And I know that they also have power, so let's talk about power. And then, in the committee, if you get stuck, the committee might help you. But it's really more, the questions are not always about getting them right. And it's more about just having a conversation about physics. And again, everybody gets through this eventually. That's our job here, is to train you, train you up to a level where by the time you graduate, you're one of our colleagues and not really a student anymore, but we're just having discussions about physics. And this is just a step along that way. That answer your question? Yeah. Question?
So I noticed you were saying Comp 2 is mostly covering undergrad topics. Is that
Yeah.
something you could take earlier than your third year then?
You can. Yeah, some people try to do it earlier if they want to. Some people get delayed for one reason or another, take it later. There, with a program as big as ours, there are always exceptions to every rule. I'm just telling you sort of the most typical. We just want to keep everybody on track. Question?
So when you get a master's?
Oh yeah, you get a master's. So after you take comps through, comps 2, I think there's like a checkbox, and you say master's please, and then you get a master's. And I think this is kind of typical for programs. I know that when I was in grad school, I did the same thing. I got sort of a couple of years through. I finished up my classwork, and I filled out a form, and I got a master's. I think it's in one of my closets somewhere. I don't want to demean a master's, but if that's where I had stopped, then maybe it would be up on the wall. But I didn't stop there. I got a PhD, and so it's sort of, anyway, you get that, I think, after comps 2, and it's quite straightforward. You just tell Jean, and she'll get you one. Question?
What's the typical time for a PhD to graduate?
Yeah, a typical time for a PhD to graduate is, maybe average is something like 6 years. I think it's often a little quicker if you're doing theory, and a little slower if you're doing experiment, because your laser breaks and you have floods and you have circuits which don't work. If you're in my lab, there's a lot of things that break. But that's sort of, I think that's sort of typical. Yeah. And then, so here we go. Yeah, so thesis defense is usually in your 6th or in your 7th. So around about, let's call it 5.5 to 6.5 years is kind of typical. I want to move us along. I've been talking for quite a while now. The remaining schedule, we're going to have Adam Kaufman, whose enormous visage is right here, give us a talk on quantum information science. And then Sasha Kempf, both of these are physics professors. Sasha is going to give us a talk about space and planetary science happening at CU and internationally. There's a number of things that are going on. There's going to be a poster session, which is going to be just outside in the hallway on this floor and on the floor one up, on the 4th floor. So don't forget about the 4th floor posters. And then we're going to have some walking tours of the physics department and JILA buildings. And we're going to leave from right out here. So right around the poster sessions. We'll yell when that's about to happen. And this is meant to just be a sort of a quick breeze through to give you a lay of the land. And then there's some, a pretty significant open part of the afternoon where you can just go meet with people. And if you haven't set up meetings with any individual professors, you're welcome to do that. You're welcome to go back and visit some of the labs that we swing by on the tour, or you can go get a cup of coffee and catch up on your email or whatever you want to do. At 4:15, I want everybody to reconvene on the 11th floor of the physics tower. And so as you're walking on the tour, pay attention to where the physics tower is. And we're going to go up, take the elevator up to the 11th floor. And there's going to be a Q&A session with just grad students. So nobody over 40 is going to be allowed in the room. And I have found that students, you know, there's just things that you might want to ask somebody who's not a potential employer, you know, and so you can ask whatever you want to the grad students. During this time, I'm going to be in my office, and at some point, one of the grad students is going to send me a text and say, all right, Tobin, you're allowed in the room now. And I'll come up and I'll join you and I'll answer any questions that I can answer from a faculty perspective. And then we're going to walk over and have our banquet at a sort of a nice dining room at the foot of the football stadium, which is, you know, where they have all the nicest dining halls. So let me wrap it up here and I'll hand it over to Adam. And thank you very much. And it's just really nice to see you all.